Welcome back to All This Math. This is Professor Parker, and for this lesson, we're going to talk about solving radical equations, but we're going to talk about solving a certain type of radical equation, a radical equation that has an expression on the left side of the equation that's set up like a trinomial, 1, 2, 3 terms, all right? And also this equation, it came from a tutoring session I was involved in earlier tonight, and I was a little stumped actually at first, but I was going through the problem in a traditional way, in a way that I would have used if I was dealing with a radical that had two terms inside of it, like, like the square root of 2x minus 4 or something like that, right? But I didn't realize at first that there's a trick to these problems, right? There's a trick to these problems. So while I was involved in the tutoring session, I didn't realize the trick to these problems, but I'm about to break it down now, all right? But before I do that, I definitely want to give a rest in peace to this brother that's here on my t-shirt. This is the late, great Chairman Fred Hampton of the Black Panther Party for Self-Defense, a leader in the Chicago area of the Black Panther Party for Self-Defense, a solid brother, a revolutionary, a freedom fighter, assassinated by the Chicago Police Department and also the FBI in 1969, and also the political structure of Chicago in order to maintain the status quo out there, so that some of the problems in our community that exist in 2022 right now, they are an outgrowth of the fact that this brother had to be taken out so that changes would not be made back then. So shout out to Chairman Fred Hampton. All right. Now, on to this. So what we see is we have what looks like a trinomial. Well, it don't look like a trinomial. It is a trinomial. Square root of a minus 3 times the fourth root of a plus 2, that's a trinomial, is equal to 0. So when you have radicals, right, that only have one term underneath of them, we can do something called substitution, right? We can substitute. But before we do that, I want to make it look even more clear. So I'm going to rewrite this equation, right, with the radicals. I'm going to rewrite them as in they are with rational exponents, all right? So I'm going to change the square root of a to the 1/2 power, all right? A to the 1/2 power minus 3 times a to the 1/4 power plus 2 is equal to 0, right? Now, why is this to the 1/2 power? Because there's an invisible 2 right here. Whenever you see a radical sign with no number written, there's an invisible 2 right there. And this exponent, there's an invisible 1 exponent right here. So the exponent from here is going to be the numerator. And the root, or the index, we call that an index. The index, which would be right here, that becomes the denominator. So there's an invisible 1, that's the numerator. Invisible 2, that's the denominator. In this term, the fourth root of a, there's also an invisible 1 exponent. That's the numerator. And there's a 4. The 4 is written, and that's still the denominator. So we have a to the 1/4, right? Plus 2 equals 0. Now, we want to get rid of these terms that have rational exponents, so we can rewrite them and represent them as an x term and an x squared term. So that way it looks like a quadratic trinomial that we can factor and solve, all right? We want to create a quadratic trinomial that we can factor and solve. So what we're going to do is we're going to say, okay, well, let's let x equal a to the 1/4 power, right? Now, why would we do that? Because again, we want to set this up and make it look like a quadratic trinomial from algebra 2, right? Or from algebra 1, where we have an x squared term, x to the first power, or just an x term and a constant, right? So basically we're going to make this a to the 1/4. We're going to let that be x, all right? Now, if that's x, then our x squared is going to be a to the 1/2. Now, why does that make sense? Because if x is a to the 1/4, right? What happens if you square x? If you square x, now you got x squared, but you would also have to square a to the 1/4. So check this out, right? That's equal to a to the 1/4 to the second power, because x squared, right, is the same thing as a to the 1/4 squared. So kind of look at this right here, right? So x to the second is the same thing as a to the 1/4 to the second. Because remember, I already said x is equal to a to the 1/4. So x and a to the 1/4 are the same exact thing. So if x and a to the 1/4 are the same exact thing, that means that when I square x, I get a to the 1/4 to the second power. Now we're going to use those exponent rules we learned in Algebra 1, right? The power of a power rule. The power of a power rule, right? So we multiply this 2 times the 1/4, and we get a to the 2/4 power, which is the same thing as a to the 1/2 power. So this is what I just did. I just proved that x squared is a to the 1/2 power. I just set it up front, but this is the breakdown. This is why, because again, x is equal to a to the 1/4, right? I said that from the rip, right? X is equal to a to the 1/4. Then I'm saying, well, that means x squared is going to be a to the 1/2, right? And why is that? Because if x is a to the 1/4, then a to the 1/4 squared is the same thing as x squared. A to the 1/4 squared, x squared, because a to the 1/4 is x, right? And then you just use the power of a power rule to simplify. 1/4 times 2 is 2/4. 2/4 is the same thing as 1/2 when you reduce it. So we got a to the 1/2. So now we can rewrite this equation, right? We're going to rewrite it using x and x squared. X and x squared. And once we do that, everything should be cool, right? Then we're going to solve for x. And then we're going to go back and we're going to solve for a. Once we know what x is, then we're going to go back and solve for a. And then we're going to check our work and check for extraneous solutions and all of that. All right, so this is going to be a to the 1/2, same thing as x squared. So I got x squared minus 3x plus 2 is equal to 0, right? Now, quadratic trinomial. X squared minus 3x plus 2 is equal to 0. I can factor this, right? Using like a reverse FOIL method or whatever you might call it. We're going to set up two binomials, right? So I do one binomial, another binomial, put an x right here, put an x right there. I'm looking for two factors of positive 2 that add up to -3. Two factors of positive 2 that add up to -3. I know they are -2 and -1. So I'm going to put a -2 right here, put a -1 right there, equals 0. Then I'm going to solve this. I know x minus 2 equals 0. So that means x equals positive 2. And if x minus 1 equals 0, then that would mean that x equals positive 1. Right? Now, we just solved for x, but the original equation has a's in it. So that means we got to go back and solve for a using these x values. So if x is equal to a to the 1/4, because even though this is like, it is an equation, but we use it kind of as an expression just to figure out what x could be equal to. But at the end of the day, it is an equation. So if we know that x is 2, then we want to solve for a when x is 2. So we're going to do this. Instead of having x equals a to the 1/4, we're going to have 2 equals a to the 1/4. Right? Because x is 2. So x and 2 are the same thing. So therefore, I can replace x with 2. And now I got 2 is equal to a to the 1/4. So now the way I solve for a is I got to get rid of this exponent. So the way I get rid of the exponent is I basically just multiply or raise that to the power of 4. And I do that on both sides, right? Because that's going to give me a to the first power. That's why I raised that to the 4th power. Because I'm looking for a. I'm trying to isolate a by itself. So I want a to the first power. So 1/4 times 4 is 1. So that gives me a to the first power. And if I do this on the right side of the equation, I also do it on the left side of the equation. So 2 to the 4th power is not 8. Don't make that mistake. 2 to the 4th power is not 8. 2 to the 4th power is 16. So I got 16 is equal to a. All right. So that's one of my, so when x is 2, a is 16. That's one of my values, right? We still have to check our work and see if it's extraneous or not. But now we're going to do the same thing with 1 using the same equation. So now we're going to say, okay, well, 1 is equal to a to the 1/4, right? Now we want to solve for a. So we got to get rid of this 1/4 exponent. The way you get rid of the 1/4 exponent is by using the power of a power rule. And we're going to raise this to the 4th power. Why to the 4th power? Because that's going to give me 1/4 times 4, which is going to give me 1. And that's what I want. I want a to the first power because a to the first power is the same thing as just a. So that's what I want. So then I'm going to have to the 4th power. And because it's an equation, if I raise it to the 4th power on the right side, I got to raise it to the 4th power on the left side. 1 to the 4th power is still 1. and this over here is A. So I got two values for A. I got 16 and I got 1. Now I need to go back and check my work. So let's do that. Let's put our check up here. So we're going to replace, first we're going to do this one at a time. We're going to replace the A's with 16 and see if that checks out. Then we're going to replace the A's with 1 and see if that checks out, to know if either of these are extraneous solutions. Because these are solutions, 16 and 1, but we don't know if they're true solutions. All right, they might just be extra or extraneous. So I'm going to replace the A. I got square root of 16 minus 3 times the fourth root of 16 plus 2 is equal to 0. And I want to know if that's a true statement. I want to know if this is real. So the square root of 16 is 4. The fourth root of 16 is 2. So that's minus 3 times 2. Then plus 2 is equal to 0. So order of operations, negative 3 times 2 is negative 6. So we got 4 minus 6 plus 2 is equal to 0. 4 minus 6 is negative 2. Negative 2 plus 2 is 0. 0 equals 0. So that means that 16 is good. 16 is a good answer. 16 is good. All right. Now we got to check 1. All right. So now we're going to say, okay, do the same thing. Replace the A's with 1. Square root of 1 minus 3 times the fourth root of 1 plus 2 is equal to 0. This is going to be 1. This is just 1. So negative 3 times 1, that's minus 3. And then plus 2 is equal to 0. 1 minus 3 is negative 2. Negative 2 plus 2 is 0. And this one checks out also. So these are our two solutions. So basically, this is a good problem. This is a good problem because it's a reminder that when the problem is set up like this, when you have these radicals, right, that are kind of related to each other, like a to the 1/4 and a to the 1/2, like this right here is just this squared, right? So you can do a substitution method, right, where you can let x equal 8. You can represent this with an x, and you can represent this with an x squared. So whenever you see a problem that's set up like this, like a trinomial, and it kind of looks like it could be a quadratic trinomial, which is what we ended up with right here. Whenever you see a problem set up like that, think to see if you can do this. If you can do like a substitution method, right? And then just work it out. Use a substitution method, treat it like a quadratic trinomial, solve for it, solve for x or any variable that you decide to use. You ain't had to use x, I just decided to use x. And then you go back using one of these equations. We could have used this equation, but go back using one of these equations and solve for the original variable. Solve for the original variable because the answer is not 2 and 1, right? That's just the value that you got that you used in order to make the work easier. You go back and you figure out what A is based on the equations that you set up in order to change from one variable to the other. All right, and we got 16 and 1. All right, that's a coincidence that it's still 1 anyway, but yeah. And then you go back, of course, always check your work with radical equations because, well, you really should check your work with any type of equation, but definitely with radical equations because with radical equations, you can find out, you can do all the math correctly, find a solution, but it not be an actual solution to the equation. It might work out, but then when you plug it back into the original equation, it may not. And that's what happens when we get extraneous solutions. Those are called extraneous solutions. All right. So again, I showed you this method. I showed you what to do when you see a problem that you see like this, but the way you're going to really learn it is by going out and practicing a bunch of problems that look just like this. So ask your teacher for problems that look like this, or just find some problems that look like this in your textbook and just get to work. Go get some practice. All right. And always do remember the late Chairman Fred Hampton. All right. Now I'm about to go make some more videos. I'll catch up with y'all later. Peace.